All right, you're welcome to my YouTube channel. You're welcome back again. So in today's video, I want to simplify this exponential problem. We have 2 over 3 to the power of 2 over 3. We want to simplify this. We want to evaluate. I just want to simplify to the simplest form of it. So how can we solve this problem? Okay, so if you are new to this channel, please don't forget to subscribe, like, comment, and also share. Okay, and click the notification button so that anytime we upload video, you'll be the first to watch. All right, guys, so let's dive into the solution. So how do we solve this problem? Your law of indices is very important if you want to solve this kind of exponential problem. If we have before I write out the law of indices we're going to be using, let me write out the question. We have 2 over 3 to the power of 2 over 3. Now I can actually rewrite these as 2 over 3 to the second power, then to the 1/3 power. All right, because 2 times 1 here will give you 2 over 3 back here. Do you understand? Like 2 times 1 over 3, I'm gonna give you 2 over 3 right here. Then from the law of indices, if you have a to the b power multiplied by c, so this is gonna give us a to the b multiplied by c power. That's what we're gonna do for this guy now. So this means we're gonna have 2 over 3 to the second power, then everything to the 1/3 power. So 2 squared will give us 4, and then 3 squared will give us 9. So we have 4 over 9 to the 1/3 power. And then remember from the law of indices, if we have a to the 1 over nth power, so this is going to give you nth roots of a. Okay, so we can rewrite this as 4 to the 1 over 3rd power over 9 to the 1/3 power, right? So this gives us cube roots of 4 over cube roots of 9. All right, so that's what's going to give us. And then I'm going to write out a very important rule. Okay, so if you have 1 over nth root of a, so this will be equal to 1 over nth root of a multiplied by nth root of a raised to the power of n minus 1 over nth root of a raised to the power of n minus 1. All right, so take note of that. It is very, very essential and very, very important. Okay, guys, now let's move on. So we're gonna apply this particular rule in this problem to make it so easy for us to solve. Okay, now let's do that. So this means cube root of 4 over cube root of 9 multiplied by what? That will be multiplied by cube root of 9 raised to the power of 3 minus 1 over cube roots of 9 raised to the power of 3 minus 1. That is what I'm saying. Okay, so this will be equal to cube root of 4 then multiply by cube root of 9 raised to the power of 3 minus 1. So 3 minus 1 will give us 2. So we have 9 squared then over cube root of 9 squared. So this will be over cube roots of 9. Yeah, this is actually beautiful. So cool. So this will be equal to cube root of 4, and that is 12. I mean, no, we can find this cube root of 4. Sorry for that. So we have cube root of 4 then multiply by 9 squared will give us 81. So we have cube root of 81 then over cube root of 9 multiplied by cube root of 9 squared. So that's going to give us cube root of 9 to the 3rd power. All right, so this will be equal to cube root of 4. Then you know that 81 is 27 multiplied by 3. So this will be cube root of 27 multiplied by cube root of 3. Okay, then everything over. Then cube root of 9 cube, this we cancel out. So we have 9. And then cube root of 27, that's 3, because 3 multiplied by 3 multiplied by 3 will give us 27. So cube root of 27 will give us 3. Then we have cube root of 4 multiplied by 3 multiplied by cube root of 3 then over 9. So 3 here 1, 3 9, that's 3. So then cube root of 4 multiplied by cube root of 3, so that's going to give us cube root of 12. So we have cube root of 12, then everything over 3. So that is the answer to the problem. Therefore, 2 over 3 to the power of 2 over 3 will surely give us cube root of 12 over 3. So that is the answer to the problem. Alright, so if you like this kind of video, please don't forget to subscribe to my channel, like my videos, comment, and also share. Thanks for watching. See you next time. Bye.